Hello YouTube, this is Cooking Components again. Today I have this beautiful power station for you, which needs to be fixed a little bit because as soon as I turn it on, it's getting noisy. Yeah, it's noisy. So I think the issue here is kind of an overheating issue, but it's hard to figure out because you can, but you cannot easily read out the temperatures which are measured all over inside of this device. So if you come from Germany like I do, you cannot find out anything about your battery because nothing happens if I click on the top left corner of the screen. It took me quite a long time to figure this out, and I already tried to use a Python script to read out the battery status information via Bluetooth, like voltages and temperatures. But if you go back and go to your settings, change your language to English, go back to data and BMS maintenance, then suddenly there are clicks in the left corner and hey, we get a status and the temperature for the power train, however it's called. Yeah, it's now at 74 degrees C. It's way too high. I had it on 62 degrees before, and that's the reason why the fan's constantly running. So there's something wrong in the device, most probably with the temperature sensors, because I have nothing turned on in this device. So all power outputs are off, and still there's a high temperature. Sometimes it's changing, and yeah, we need to take it apart and figure it out. So this behavior started with the fans ramping up occasionally while the device was powered on but no load, and then it got more often, and now it's constant. So you can see still 73. Okay, got down a little bit. I can yank it. Nothing's happening to the temperature sensor, so it's not like a bad contact. I think maybe the sensor's bad. I don't know. We'll need to figure out. But hey, all the other temperatures are in line. They're okay, I guess, and the voltages look good. So I think it's a dead sensor. The only way to find out is by taking it apart. Okay, yeah, let me just start taking this apart. Oh wait, perhaps I should shut it down before. Yeah, nice. It's so much quieter. Nope, I didn't take all the caps off. So they are quite nice to remove. Ignore this small hole here. Just get something in there and it's easy. Nice. Okay, this is a little bit annoying with the cable of the wireless charging pads. So I lift this up. Okay, and then there are two cables. And these need to be removed first, but they are glued down there. So I'll try to scratch off the glue. Or the silicone adhesive or whatever it is. Oh, that's not good. That's annoying. You know what? I hate these wireless charging pads. I never use them, but as soon as you turn on DC power, they are constantly sucking power. They are waiting something to charge, but you cannot turn them on separately. So, yeah, you always waste a lot of energy to them running in standby, even if they are not used. It's annoying. So I'll try to get the cable out. Give me a sec. Yeah, first one. Second one, and away with them. Beautiful. Yeah, now I need to figure out which cables to separate first. So I hope now this is in view for you, without too much reflection. So first of all, we are going down to these two cables which connect the battery. And I don't know why there are two coming off, perhaps for sharing the load. I'm not sure, but that are beefy connectors, so yeah. Yep, first one out. Second one out, so I hope they don't touch any screw, because a screw might penetrate here and short something. So we need to be careful. And then these two connectors, which are silicon down quite good. Can I get the silicon off? Yeah, in parts. Okay, that one's gone. Ah, come on. Yeah, that's one off too. Screen. That must be the screen cable for the touch screen. Some big fat connector to the power board and another one. Yeah, I think that's it. We should be safe. Okay, so I searched for temperature sensors, and there is one down here on the heatsink and one down there on the heatsink, and both of them go down there to the connectors which are completely covered in silicon. And on the other side of the device, there's a temperature sensor here on this heatsink, which is connected way down there, also covered in silicon glue. And another temperature sensor here, which is connected down there. And I just noticed there is a fan header with a cable running off to the fan. Oh, that's a small one, a thin one. And back there is a thick one. So I should have ordered other fans so I could replace them with fans that are not so noisy. But I didn't think about that. Okay. Maybe later, maybe never. Who knows? And I've got the multimeter here, set to ohms range. And yeah, let's give it a try. So the first temperature sensor, 18.5 kiloohms. The second temperature sensor, 18.9. Third one, oh, that's annoying with these connectors. 18.9, more closely to 19 kiloohms. And the fourth one, 18. So all temperature sensors are okay? No, not quite. I've measured this one before and it gave me completely wrong readings. So I don't know why it's reading correctly now. Man, that's making a fool out of me. Come on. You can do it. You can fail again. Something's happening there. I put a bit of mechanical strain on the sensor and now it's only reading. Oh, it's going up. Was it just the heat from my finger? Oh, it's reacting good. So I got when I disconnected this and tried it without running camera because I forgot to turn it on, I got a lot lower, I think 4 kilo ohms or 2 kilo ohms around that. And now I get good readings again. Oh, that's strange. That's making a fool out of me. So that looks like perfectly normal readings. So I touched the sensor, so it got warm and the resistance dropped, and now it's getting back up because the heat is running away. Looks plausible to me. But I've seen wrong values before, so maybe there's still something not correct, but hey, we can just try again with the now seemingly fixed temperature sensor and look what the system thinks about this temperature sensor and how it behaves. Perhaps we have fixed it, but then we have to remember that this temperature sensor is dicky and we should get a replacement. So I connected everything back up, but not the battery. So I'll just connect the battery now and then we'll try and find out if this actually fixed it. And if it fixed it, I'll try to find a new sensor because this one is clearly dicky. And if it didn't fix it, it's something else. I don't know. Oh, these connectors scare me. Okay, they are in. Time for the magic moment. Nope. Okay. 71 degree. I don't know. Can you see it? Yeah. I don't know. Time to disconnect everything again, I guess, and search for another fault. Or at least check the one sensor again. Maybe I can just pull it out, but let me at least disconnect the battery. Oh, I had this. Aha. 2.6K. Where's that coming from? Now the temperature sensor got dicky again. I mean, I can check if it's hot. Nope. I can wiggle it. goes even lower because my finger is now heating it up. And believe me, it's not hot down there. I think at 2.6K I would just burn my finger right now. Nope. So something's wrong with this sensor. I need to get it out. So I'll just try to get this sensor out somehow without removing everything. And replace it with a resistor. And try my best. Try my luck. Whatever. Nope. Ah. Oh. No. No, it's just skipping. Yeah. Try to find something else. I know these are not the right pliers, but I had them laying around. Oh. Screw moved. Did it move? I'm not sure. Okay, yeah, it moved. Sorry, I know you can't see. It's a long screw. I didn't expect that. Oh, yeah, there's it. There it is. It's out. Beautiful. There's our sensor. Let me just grab the screw. There is nothing written on there. Nothing helping us identify the sensor. Not on the connector, not on the sensor side. The cable has some writing. Yeah, but the writing only says that it's a 26 gauge, that it is rated to 105 degrees, etc. Nothing about the sensor. So, yeah. We'll need to figure it out another way, but now let me just replace it with a resistor and check if it's that and if it's working again after replacing it with a resistor. Through the magic of video production, I got a new temperature. Okay, it's a fake one, but let me just check it. Should have around 20 kilo ohms. Yeah, 19.9. I'll just connect it and we'll give it a try. Perhaps we've fixed our problem. Yeah, and then I need to get a new temperature sensor. And for that I need to find out what characteristic this temperature sensor has and which temperature it's made for and so on, and then with a replacement I can finally fix this device. Beautiful. Yep, it's connected. Flapping around in the breeze. And now I'll just need to reconnect the battery again. 1 and 2. Yep. Yep. Went in there, and now the magic moment. Hopefully it won't explode. Okay, at least we hear static again in the microphone. Oh, it's not ramping up. Nice. Oh, it shows 19 degrees. Ooh. So as you can see, we get a temperature reading of 19 degrees C. The other sensors are closed, so indeed the forced temperature sensor is broken. Or yeah, it's still broken and we replaced it with a fake one. And so we verified that this is the problem. And we now need to fix it by removing one of the other sensors, trying to characterize it to find a suitable replacement, because the manufacturer at least did not publish openly somewhere the information, or I couldn't find it, which temperature sensor belongs there. And yeah, I need a new one, so I need to figure out which one will fit there. So to find out the nearly exact values of these temperature sensors, I prepared myself a measurement setup. By the way, I don't really trust the value of this temperature meter. I see these K-types, summer couples, more like a rough estimate. I'm not sure if this is true, but that's the way I think of it. So I want to prepare water on different temperatures. So I got myself a bucket of ice water, and I got myself a bucket of boiling hot water. And when I mix them in the right amounts, I should get 25 degrees C water. And 25 degrees C is the temperature these sensors are rated on. So when you buy an NTC with 10K, for example, it has this 10K resistance at 25 degrees C. So to get 25 degrees C, I need 150 milliliters of ice water and 50 milliliters of boiling hot water. And yeah, that's around 50 grams and 150 grams, which gives 200 grams. That's a little bit too much. Okay, I think I shouldn't overdo it. Ooh, that's nice. So now I need something to stir it, which hopefully will not take too much temperature energy out of the equation. So I use a plastic stirrer. Yeah, could be a little not enough temperature, but I don't trust this meter, so it's okay for me. And now I hope this is water safe. It takes a while to settle. Okay, this is not a value I would have expected. I would have expected something like 10, 15, 20, 100. Okay, not from the sensor, but I think you know what I mean. Okay, 16.63. Is this something I can buy? I'm not sure. Okay, now the next measurement point we can take. I'll change the measurement setup. Don't forget to stir your ice water, because it might separate. So you don't only have 0 degrees Celsius water on the top and perhaps 4 degrees Celsius water on the bottom. Okay, here comes the measurement point for 0 degrees Celsius. Oh no! There's ice in my ice water. I need to get it out. Might throw off the measurement. I think my water's warming up. You know what? This glass bowl, I didn't cool it down. So this is throwing my measurement off because it's heating the water. That's not good. I mean, I have here this plastic beaker, but the ice is in there, so that might even be colder. I need to find a solution. Okay, and now let me measure this. Aha, so this water cannot be cooler than 0 degrees C, because then it should be ice. I mean, it's not that clean that it would be super cooled water, but yeah, I guess we get our reading now. Let me add this one too. Okay, I need to watch the video to find out which was the coldest point. Yeah. Okay, it's just warming up because we have around 22 degrees C in this room, so it's throwing off our measurement. I mean, even the measurement on the multimeter is slowly getting warmer. And for the last measuring point, boiling hot water. So regarding the boiling point of water, this one changed with the pressure of the air surrounding it. And from my weather station, I know it's at the moment 985.5 hectopascal. And ChatGPT states that water will then boil at 99.3 degrees C. If you consider that we would have some losses due to the thermal mass of the cup, let's say it's 99 degrees Celsius. And in comes the water. I hope the cup doesn't break, but it should be okay with boiling hot water. Yeah, and I think we have our measurement. It's amazing how fast the water gets cooler. So maybe now that the cup is hot, I should do a new measurement. And here comes the fresh water. No, stirring won't help. Still could be cold. I think we have our minimum value, so I'll try my best to find my sensor. So it has been a couple of weeks now till I did the measurements, and I've been searching around on the internet a lot, like on the big distributors like Mouse and Dicky, and I could not find a lot of 16 kiloohms at 25 degrees C temperature sensors. And I just guessed, okay, I think my measurements are off by quite a bit. At least for the temperature, like 25 degrees C or 24.4 degrees C. I think that's off by a lot. And I also used a tool to somewhere on the internet to calculate the beta value. And yeah, okay, between 0 degrees C and 25 degrees C, yeah, my measurement is off, so I cannot trust my beta value. But I think the measurements like 0 degrees C and 99 degrees C, they are apart very far on the scale, and they are done in a way that gives me a higher confidence in the temperatures. And even if these are off by 1 or 2 degrees C, they are very far apart. So I can somewhat trust this beta value. And then I focused on the ring cable lug, which is used for mounting the temperature sensor. And for that, I can even find a lot less temperature sensors. And the only one I could find are 10K, 15K, and a 100K. And 15K is not very common, but it's the only temperature sensor I could find that roughly fits our measurement at 25 degrees C, but fits the beta value quite nicely. I mean, yes, it will be off by my measurement, but I could find these temperature sensors, 15K, and a beta of 3915, and my measured or calculated beta is 3981. So yeah, I just bought these sensors on AliExpress because it was the only site I could find them, or it was the only site I could find them complete in the bag, cable lug, connector, beautiful. So I will just measure them against a known functioning sensor, and yeah, if it fits close enough, I'm good with this. So here I've got both sensors, the old one with the silicon on the connector and the new one with a very long cable and no silicon on the connector. So I have both of these sensors screwed together, so they will have roughly the same temperature, as at least when I get them far away from my warm hands. And I'll just measure them and compare the values, and then I will drop them in warm water and see how they behave. And I hope they behave the same, and we can just use new sensors and my power station will be good again. So I'll connect the old sensor to the left multimeter and the new sensor with the long cable to the right multimeter. Oh, and I should set the multimeter to ohms range. And yeah, they are both rising because I have put my hands away and they are cooling down. But they look quite similar. I like that. And here's a cup of hot tap water, which has been standing around for, I think, half an hour, so it's only warm, not hot, but perhaps it's enough for this measurement. Let me drop them in. Oh yeah, they are changing fast. So after a couple of minutes of settling, the temperature is falling because the water is cooling down, which means that the resistance on both sensors is rising. But as you can see, it's not so far apart. It's around 30 to 40 ohms only. And we are measuring in the kilo ohm range. So I think they are quite close. And I can just replace the temperature sensors in my power station or the broken one. I don't need to replace all of them. And I can get my power station back working. I liked it. Beautiful. I think I found matching sensors. So I'm trying to give you a close-up of these sensors so you can see for yourself that they look quite similar. So the casing, the epoxy used, the cabling, everything looks the same. The connector, where's the other one? They look the same. I mean, the new sensors obviously missing the silicon, but it has never been installed before. And yeah, when I mount the sensor, I could add some silicon and then they would look the same. Probably. But yeah, I think they are a good match. They might be even coming from the same factory, being the same product. I'm not 100% sure because the markings on the cable look a little bit different. So the text is a little bit smaller and the spacing is different, but it's the same text. I don't know. For me, yeah, it could be the same sensor, same manufacturer. I don't know because I don't know what's the original sensor's part number or manufacturer. But yeah, I'll just put them in and hope they are working. Beautiful. Oh, and there's still the fake sensor inside. Oh, let me remove that. So to get to the screws, I need to get a little bit creative. I'm just too lazy to take apart the whole unit. Okay, maybe I can just use my fingers there. So first I'll try to get the sensor back in there that I used to make my reference measurements. Oh man, I don't like that. Okay, it's in there. And now I need to get a little more creative. It's not funny. I hope that's tight enough. First sensor in. should be tight enough, and have all of this cable. Yeah, I think I need to tie it down somehow. But first, let's just try if this thing works or not. I maybe will tie it down now. Yep, think I should do that. Back there is a hole, and I think I can make use of that hole. Okay, I'll just reconnect power. Now the magic moment. Okay, I can at least hear some of the power supplies in the microphone. Yeah. And the device turned on. Okay, data, maintenance. Okay. You can't see what I can see, can you? Yeah. Okay, so fans are not running like before, so that's good. And my temperatures look good. Nice, I like that. So I would call that a fix, and we just need to put everything back together. Yep. Yep, looks good. I like that. So I was curious and took one of the wireless charging units out. And yeah, it's just a PCB with a small little chip on it. And charging coil with heavily insulated wire, which is stuck down onto a thin piece of ferrite material to, I think, steer or enhance the magnetic field. Yeah, and it is just stuck on some foam to give it, I don't know if it needs distance to the PCB, but yeah, to get it closer to your phone. Yeah, so yeah, interesting little thing. And I decided to measure the power consumption of this wireless charging device. And yeah, when you don't have your phone down on the charging spot and you have turned on the DC rail of your power station, because when you turn on the DC rail on your power station, they will turn on too. You might not want to use the wireless charging, but use some of the USB ports or the car out port or the 12-volt port or whatever what is running on DC voltage. Yeah, they are constantly running, and I measured them. They take around 150 milliwatts when no phone is close, and I could charge my phone with it, and then they take 7.4 watts. And remember, you have two of them, so both of them will take 150 milliwatts, or together 300 milliwatts when you have DC on and no phone on them. So you're wasting some power, but it's not a lot. I've got myself some silicon sealant, and I'll just glue the connectors down again so they cannot rattle loose. As you can see, I already removed the old one as best as I could. And yeah, I'll just squeeze some new on there. Yeah, nice. And a little bit on the side. Yeah, we have enough of that, so I can be a little wasteful. Well, that's smelly. And I'll do that on all of the temperature sensors, and then I'll put it back together. Beautiful. And while gluing down the last two connectors of the wireless charging, I think I'll start reassembling the power station. Oh, that's the wrong way around. That does not feel promising. I mean, how they clip in, or perhaps I had the wrong one. Are they different? Oh yeah! The back one is different. Now they fit. Nice. Will it turn on? Yeah. I can hear the sound in the audio. Nice. Yeah. Turned on. Didn't explode. Nice. Temperatures look good. I think that's a win. Okay. I think that's all for today. Thank you for watching. Leave a like, comment, subscribe, all the good stuff. Thank you for watching and see you in my next video. Bye. Yeah, I know. This video would not be complete without a test, so I've got a kettle. I hope this will work because the power station is rated to 2200 watts, but the kettle goes from 2000 to 2400 depending on the voltage, and I'll just give it a try. Oh, instant fan speed. Because there's a lot of load, so I turned on immediately. And I can read 2050 watts, so we are good. Yeah, it's sucking in air on this side, so I hope it will not get the steam from the kettle. Can we watch the temperature rise? Ah, okay. Perhaps a little bit here and a little bit here, but nope. Staying cold. Oh, yeah, I don't like that steam, so... Oh, it's done! Beautiful! And the fan turned off because the load is gone and... it's still cool. Nice, so I could use a cup of tea. Oh, I didn't get a tea bag, so it's only a cup of hot water. Bye.